Find somewhere comfortable. You don't need to sit up straight or keep your eyes open. You don't need to hold on to any of this. Just let the words come to you the way warmth does, slowly, without effort, from the edges inward. If today was hard, you don't need to explain that to anyone tonight. If your mind is still turning something over, that's all right. You don't have to put it down right now. It can rest beside you. We're going to travel somewhere very far away and very long ago, somewhere so ancient and so vast that the ordinary worries of a Tuesday or a Thursday become, for a little while, very small and very distant. We're going to follow a piece of light, a single tiny piece of light, born in the heart of the sun, in a fire so deep and so old that it predates everything you have ever known. We're going to follow it through the dark interior of a star, through the silence of space, and all the way here, to this room, to the skin of your closed eyelids. It is a long journey, longer than you might imagine. We are in no hurry tonight. There is something almost impossible to hold in the mind about the sun. We see it every day. It rises, it moves, it sets. It feels familiar, even ordinary, the way a mountain in the distance can start to feel ordinary if you live near it long enough. But familiarity is not the same as understanding, and the sun, looked at closely, is one of the strangest and most patient things in the universe. The light that fell on your face today, on your hands, through a window, off the surface of the floor, that light did not begin its life this morning. It did not begin its life this year, or this century, or anywhere near the span of a human lifetime. The energy that became that light was forged in the very center of the sun, somewhere between 10,000 and 100,000 years ago, depending on which path through the solar interior it happened to take. It wandered, blind and aimless, through layer after layer of the sun's body, nudged and redirected billions upon billions of times, until at last it found its way to the surface, leapt into the void, crossed 150 million kilometers of empty space in just over 8 minutes, and arrived here. Here, on Earth, on you. That is what we are going to explore tonight, not as a science lesson, just as a story, a very old, very slow, very beautiful story about a piece of light trying to get home. To understand where our light begins, we have to go somewhere no human instrument has ever directly seen, and no human body could survive for even the smallest fraction of a second. We have to go to the core of the sun. Picture a sphere, not a large sphere by cosmic standards. The sun is a fairly ordinary star, middle-aged, unremarkable in the grand catalogue of the universe, but large enough that roughly 1 million Earths could be packed inside it. And at the very center of that sphere, compressed beneath the weight of everything above it, is a region of almost incomprehensible density and heat. The temperature at the sun's core is somewhere around 15 million degrees, not the kind of heat you feel stepping onto hot sand, or even the kind of heat inside an industrial furnace. This is heat so extreme that matter itself behaves in ways that have no equivalent in ordinary life. Nothing solid exists there, nothing liquid. Everything is plasma, a state of matter where atoms have been stripped of their outer parts entirely, leaving only bare nuclei and a sea of free electrons, all moving at speeds and energies that make the word hot feel almost comically inadequate. And the density, the core of the sun, is about 10 times denser than lead. If you could hold a piece of it the size of your fist, which you could not, for reasons that go beyond the obvious, it would weigh roughly the same as a large car. Yet it is not solid, not in any way we would recognize. It is gas. Plasma. The density comes not from rigid structure, but from sheer gravitational compression, the weight of an entire star pressing inward from every direction. It is in this furnace that our story begins. Under these conditions, something remarkable happens. The bare nuclei of hydrogen, the simplest atoms in the universe, each one just a single proton, are pressed so tightly together, moving so fast that they occasionally do something that would be impossible under any gentler circumstances. They fuse. 4 of these tiny hydrogen nuclei over a sequence of steps are squeezed together and transformed into something new, a helium nucleus, which has slightly less mass than the 4 hydrogens that went into it. That missing mass does not disappear. It is converted directly into energy, in accordance with a relationship so elegant and so deep that it underlies the shining of every star in the sky. A very small amount of mass becomes a very large amount of energy. This happens continuously in the sun's core every single second of every day, and has been happening for about 4.5 billion years. The numbers involved are difficult to feel. In every second, the sun converts roughly 4 million tons of its own mass into pure energy. Not 4 million tons of fuel burned, 4 million tons of matter simply ceasing to be matter and becoming light and heat instead, every second. 4 million tons. Gone. And yet the sun is so vast that this represents only a tiny fraction of its total mass, and it will continue doing this for another 5 billion years or so before it begins to change. Each fusion event releases energy in the form of a photon, a particle of light, but not the warm, golden, gentle light that you know, not sunlight, not anything visible. The photon born in the core of the sun is a gamma ray, which is a way of saying it carries an enormous amount of energy, far more than visible light, far more than the ultraviolet that burns your skin on a summer afternoon. A gamma ray from the sun's core is fierce and violent. If you could somehow be exposed to it, it would pass through you the way a bullet passes through paper. This is our photon. At the zest for the photon. It cannot choose a direction. It cannot slow down. It cannot stop. It is simply energy moving in whatever direction the physics of its creation sent it. The core is not empty space. It is not a clear path to the outside. It is a crowd, impossibly dense, of particles moving in every direction at once. And our photon, fierce and newly made, is about to run headlong into that crowd. Imagine a room, a very large room, but packed, completely packed, with people standing shoulder to shoulder, moving, jostling, turning. Now imagine trying to cross that room, not walking around the edges, straight across from one wall to the other. Every step you take, someone is in your way. You bounce off one person and stumble left. You bounce off another and lurch right. Sometimes you end up moving backward from where you started. Sometimes you make a little progress forward, only to be redirected sideways 3 more times before you gain another inch. This is roughly what happens to a photon inside the sun's radiative zone, the vast middle layer that lies between the core and the sun's outer regions, stretching through the majority of the sun's interior. And the photon does not just bounce off people. It is absorbed entirely, ceases to exist for a brief moment, and then a new photon is spat back out in a completely random direction, not nudged, not deflected. Reborn, pointing somewhere new with no memory of where it came from. The distance a photon travels between these events, between being absorbed and being re-emitted, is extraordinarily short. On average, it is less than a single millimeter. In some parts of the radiative zone, it is considerably less than that. The interior of the sun is so packed with charged particles, so dense with free electrons bouncing around at tremendous speeds, that a photon simply cannot travel any meaningful distance before something stops it. Now, a millimeter does not sound like much, but consider the radiative zone is hundreds of thousands of kilometers thick. The distance from the edge of the core to the outer boundary of the radiative zone is something like 500,000 kilometers, and our photon is making progress across that distance in steps of less than a millimeter, each step pointing in a direction chosen at random. This kind of motion has a name in mathematics, a random walk. The image of a drunk trying to find his way home is one that physicists have used for a long time because it captures something true about the situation. A person who is very drunk takes steps, but each step is in a more or less random direction. They might go 3 steps forward, then 2 to the left, then 1 backward, then 4 to the right. They are moving. They are covering distance. But the net progress toward home is agonizingly slow because so much of the effort cancels itself out. What mathematics tells us about a random walk is this. The distance you actually travel grows much more slowly than the distance you cover in total steps. If you take 1,000,000 steps in random directions, you do not end up 1,000,000 steps from where you started. You end up much, much closer to the beginning because all those steps in different directions keep undoing each other. The net displacement, the actual progress made, grows only with the square root of the number of steps, which means that to go twice as far, you need 4 times as many steps. To go 10 times as far, you need 100 times as many. Applied to a photon trying to cross the sun, this means something almost poignant. The total distance that photon's energy travels, the sum of all those tiny hops, all those millimeter-long dashes in random directions, is almost incomprehensibly large. The number of individual absorption and re-emission events has been estimated at something like 10, followed by 25 zeros. Each one is a tiny step. Each one could point anywhere, and the net result, the slow outward drift that eventually carries the energy from the core to the surface, takes tens of thousands of years. Light, moving at the fastest speed the universe allows, trapped in a random walk so thorough that it makes almost no reliable outward progress at all. There is something quietly humbling about this. We tend to think of light as fast, and it is. In open space, in a vacuum, nothing travels faster. But speed is not the same as progress. A river can flow very quickly and still take a long time to reach the sea if it winds and doubles back and spreads through delta after delta. Our photon, or rather the chain of photons that carry its energy forward, is doing something like that. Moving at full speed, always, in whatever direction it finds itself pointing, but making net outward progress at a pace that makes a glacier look hasty. The radiative zone through which all this happens is not a place of drama. It is utterly dark. There is no light to see by. The photons that exist there are absorbed almost as soon as they are created. It is hot, extraordinarily hot, though cooler than the core. The temperature drops as you move outward from 15 million degrees at the center to perhaps 2 million at the boundary of the radiative zone. And it is quiet in the sense that nothing changes quickly. The same slow churning, the same endless absorption and re-emission has been going on for billions of years. Somewhere in that dark, dense, patient interior, the energy that will one day warm your skin is making its way outward, one tiny step at a time, in no particular direction. 100,000 years. Try to hold that for a moment, not as a number, but as a span of time. 100,000 years ago, our ancestors were living in small groups across Africa, Europe, and Asia. They were painting animals on cave walls in what is now southern France and Spain. Ochre bison, outlined hands, deer moving in the flickering firelight of a torch. They had language, probably. They had memory. They buried their dead. They looked up at the same sun, you see, and they felt its warmth on their skin, and they had no way of knowing that the warmth they felt that day had begun its journey inside the sun before their great-great-grandparents were born. That is the scale of this story. The energy that warmed someone's hand today, that fell through a window this morning, that made a patch of floor warm to the touch, that energy began making its way outward from the sun's core somewhere in the deep human past, long before any civilization, long before agriculture, long before writing. It wandered through the sun's interior for the entire span of modern human history, and then some. And only recently, only in the last 8 minutes of that whole journey, did it cross the open space between the sun and us. It is worth pausing on that proportion. 100,000 years inside the sun, 8 minutes outside it. The journey through space is so brief relative to the journey through the star that it barely registers. The sun's interior is where the story lives. Now, there is something important to say here, and it is one of those things that sounds like it should be disappointing, but is actually more interesting when you sit with it. The photon that left the sun's surface and crossed space to reach you is not the same photon that was born in the core 100,000 years ago. Not even close. Each time a photon is absorbed by a particle in the sun's interior and a new one is released, the original photon ceases to exist. The new one carries some of the energy of the old one, but it is a different photon, a new event, a new particle, pointing in a new direction. This happens an almost unimaginable number of times over the course of that 100,000-year journey. What persists is not the photon itself, but the energy it carries, passed from one short-lived particle of light to the next, over and over and over. Think of it like a flame passed from candle to candle. If you light one candle from another, and then another from that, down a long corridor of 100 candles, the flame at the end is not the same flame that started at the beginning. But something was passed forward, something real, something continuous, and the last candle is lit because of the first one, even though no single particle of fire made the whole journey. That is what is happening inside the sun. Energy, not a particle making the crossing, a relay, not a marathon. And along the way, that energy changes character. This is another thing that is easy to miss and quietly beautiful. The photon born in the core is a gamma ray, fierce, high energy, the kind of radiation that tears through matter. But with each absorption and re-emission, the energy is shared out a little differently. The photon that is re-emitted is often slightly lower in energy than the one that was absorbed. Over billions and billions of these exchanges, the character of the radiation shifts. Gamma rays become X-rays. X-rays become something softer. Eventually, as the energy approaches the surface of the sun, it is transformed into something entirely different from what it started as. Visible light, the warm glow we see, the gentle warmth we feel. It is as if the energy has been worn smooth by the journey. The raw, violent force of a nuclear reaction passing through so many hands over so many years gradually softened into something a human face can turn toward and find pleasant. There is a kind of patience in that image that feels worth keeping. The energy does not hurry. It cannot hurry. It simply moves step by step, changed by each step, until it is ready to meet the world. While our photon's energy was beginning its long, slow wander through the sun's interior, something else was also born in that same moment of fusion, something that took a completely different path. A neutrino. Neutrinos are produced alongside photons in the fusion reactions at the sun's core, and in almost every way they are the photon's opposite, where the photon is constantly stopped, absorbed, redirected. The neutrino passes through matter almost as if matter were not there at all. To understand why, you have to understand something about how particles interact. Photons interact with charged particles, electrons, protons, very readily. That is why the sun's interior is so effective at trapping them. The dense crowd of charged particles in the radiative zone grabs photons almost immediately, over and over again. But neutrinos do not interact with charged particles the same way. In fact, they barely interact with anything. They feel only one of the fundamental forces of nature, not the electromagnetic force that governs most of what we experience, but a different, much weaker one. And because that force is so feeble, a neutrino can travel through enormous amounts of matter without ever being stopped. How enormous! A neutrino could pass through a wall of lead several light years thick, several years of travel at the speed of light. and have only an even chance of being stopped by a single atom. The entire sun, with all its density and heat in packed plasma, is essentially transparent to them. A neutrino born in the sun's core passes through the entire body of the sun in about 2 seconds and heads out into space, completely unimpeded. 2 seconds compared to 100,000 years, the same birthplace, the same moment of creation. One particle of light, trapped and wandering in the dark for an epoch. One ghost particle, gone before the echo of its creation has faded. The neutrinos from the sun reach Earth about 8 minutes after leaving the sun's surface, the same time it takes light to cross that distance, since neutrinos travel at very nearly the speed of light. And when they arrive, they do not stop. They pass through the entire Earth as easily as they pass through the sun. They pass through you. Right now, while you lie still in the dark, something in the region of 65 billion solar neutrinos are passing through every square centimeter of your body every second, through your skin, through your organs, through the bones of your hands resting on the blanket. You feel nothing. They are gone before any interaction could register, carrying their ancient energy forward into the universe, indifferent to everything in their path. There is something both eerie and strangely comforting about that. The sun reaches you in 2 ways simultaneously, one slow and warm and visible, the other instant and invisible and utterly silent. One you feel, one passes through you like a whisper through an open window. Scientists have built extraordinary instruments trying to catch these ghost particles in the act, because even though the chance of any single neutrino interacting with anything is vanishingly small, if you have enough material in one place, occasionally, rarely, one will leave a trace. These detectors are buried deep underground, away from the constant noise of cosmic radiation that would drown out any signal. Some of them are tanks holding thousands of tons of water or other clear liquid sitting in silence in the dark. When a neutrino does, very occasionally, collide with a particle in that liquid, it produces a faint flash of light, a tiny blue glow, barely there, gone in an instant. Scientists watch for those flashes, patiently, in the dark, waiting for a ghost to show itself. The fact that we can detect them at all is a kind of triumph of patience, and what they tell us is precious because unlike photons, which carry information only about the sun's surface, since the photons we see were last absorbed and re-emitted right at the outer edge, neutrinos come straight from the core. They are live news from the furnace, arriving in real time, carrying a direct report of what is happening at the very center of the sun right now. Every flash of blue in those deep underground tanks is a message from a fusion reaction that happened 8 minutes ago, 150 million kilometers away at the heart of the star that made us. After its immense, aimless crossing of the radiative zone, after hundreds of thousands of years of random steps, of absorption and re-emission, of energy slowly working its way outward through conditions of almost unimaginable density, something changes. The energy reaches a boundary, not a sharp edge, not a wall, but a gradual transition, a place where the temperature has dropped enough and the density has thinned enough that the old method of energy transport simply stops working as well. In the radiative zone, energy moved by radiation, photons carrying it forward, step by tiny step. But here, in the sun's outer third, a different mechanism takes over, one that feels, in some ways, far more familiar. The material here begins to move. Imagine a pot of water on a stove. When you heat the bottom of the pot, the water at the base grows warmer and expands slightly, becoming a little less dense than the cooler water above it. The whole pot begins to circulate, not randomly, not like the photon's random walk, but in organized patterns, great loops of rising and falling material, carrying heat upward from the source. This is convection, and it is exactly what happens in the sun's outer layer. Hot plasma rises from the lower boundary of this region toward the surface, carrying its heat with it. At the surface, it releases that heat in the form of light, in the form of radiation. Great columns of material rising and falling in slow, vast rhythms. These convection cells, as they are called, are not small. The largest of them are wider than entire continents. Some span distances comparable to the width of Europe or North America, rising and falling over the course of roughly 10 minutes before the cycle begins again. At the surface of the sun, you can see their tops, if you have the right instruments and the right filters, which you absolutely require before looking at the sun. The surface appears, under those instruments, to be covered with a fine granular texture, like the skin of an orange or the surface of a bowl of rice slowly simmering. Millions of small, bright patches, each one the top of a rising column of hot gas, each one surrounded by slightly darker borders where the cooled material is descending again. Each of those granules is roughly the size of a small country. There are millions of them, constantly forming and dissolving, appearing and disappearing on timescales of minutes. The sun's surface is never still. It seethes and shifts and renews itself continuously, an ocean of fire in permanent, slow motion. The convective zone is in some ways the most dynamic part of the sun's interior, the place where the long, patient, invisible drift of energy through the radiative zone finally becomes visible motion, becomes structure, becomes something that can be watched and mapped and studied. It is also the layer responsible for many of the features of the sun that we can observe. Sunspots, which are regions where the convective flow is disrupted by strong magnetic fields, causing patches of the surface to be slightly cooler and therefore appear darker. Solar flares, enormous releases of energy, the slow pulse of the sun's magnetic cycle, which waxes and wanes over roughly 11 years and shapes the behavior of the 11 years and shapes the behavior of the entire solar system. The energy that arrives at the top of the convective zone has been traveling since before our species walked the earth. It has been absorbed and re-emitted more times than there are grains of sand on every beach on earth. It has changed from a fierce gamma ray into something soft and golden. And now, at last, it reaches the surface, the top of the rising column, the edge of the star. Open space is just above. After everything, after 100,000 years of wandering through the dark interior of a star, the energy is about to be released. It is about to become a photon again, a real one, moving in a straight line for the first time into the vast and empty dark. The moment a photon leaves the sun's surface, everything changes. Behind it, heat, density, constant interruption, 100,000 years of being stopped and redirected. Ahead of it, nothing, the vacuum of space, no particles to absorb it, no charged plasma to reach out and grab it, no obstacles of any kind for 150 million kilometers. The photon accelerates to its full speed immediately, the speed of light, which in a vacuum is the same for all light, always, without exception. It is the absolute speed limit of the universe, and in open space, light always travels at exactly that speed. Our photon, finally free, moves at that speed from the first instant of its release. And it crosses the distance between the sun and the earth in just over 8 minutes. 8 minutes. After 100,000 years. It is one of those proportions that the mind wants to reject. The journey inside the sun was so long, so slow, so filled with interruption that the final leg feels almost like an afterthought. The photon does not know, of course. It has no memory of where it came from. It does not feel the relief of open space or the brevity of the crossing. It simply moves at the only speed it knows toward whatever is ahead. Space, in this context, is genuinely empty. Not the kind of emptiness we experience on Earth, a quiet room, a clearing in a forest, but a depth of emptiness that is almost impossible to convey. Between the sun and the Earth, there are a few stray atoms per cubic centimeter, a faint wind of particles streaming outward from the sun, the occasional dust grain, But for a photon traveling at the speed of light, these are so sparse as to be irrelevant. The journey is unimpeded, straight, and silent. There is a strangeness in looking at the sun, though, again, never directly, never without protection, and realizing that what you are seeing is not the sun as it is now, but as it was 8 minutes ago. The light entering your eyes left the sun's surface 8 minutes before the moment of your looking. If the sun were to simply switch off right now, you would not know for another 8 minutes. You would go on seeing it, feeling its warmth, for 8 more minutes after it had gone dark. This is not a thought experiment or a metaphor. It is a genuine feature of how light works, of the fact that information travels at a fixed speed across space. Every photograph of the sun is a photograph of the past. Every beam of sunlight is a message sent 8 minutes ago, arriving only now. And there is a softer version of this that applies to tonight. The light that might be filtering through your curtains right now, or that fell on your face this evening, or that is reflected off the surface of the moon into the dark outside your window. That light left the sun's surface 8 minutes before it reached Earth. It spent 100,000 years working its way out of the sun's interior, and it has been traveling in some form since before there were humans to notice it. Scientists have found ways to study the sun's interior without being able to see inside it directly. The method is elegant and patient, and it works by listening. The sun rings like a bell, not in a way you can hear, but in the sense that waves travel through its interior, bouncing back and forth, creating patterns of expansion and contraction on its surface that can be measured very precisely. By studying these waves, the way a doctor might listen to the rhythm of a heartbeat to learn something about the health of the heart, researchers have been able to map the sun's inner structure in remarkable detail. They can trace the boundary between the radiative zone and the convective zone. They can detect changes in temperature and density at different depths. They can watch, over decades of observation, as the sun's interior shifts subtly from one cycle of activity to the next. Recent work using more than 40 years of continuous measurements has revealed that the sun's magnetic behavior is gradually becoming more concentrated in its shallower layers, within just 1,000 kilometers of the surface. With each passing cycle, the sun is dynamic even in its quietest moments, its interior leaving a unique fingerprint on each period of calm. What seems still and constant from the outside is, on the inside, always in slow motion. The 8-minute crossing, then, is not just a transit, it is an arrival. The end of a journey so long that calling it a journey almost undersells it. And what meets the light on the other side of that crossing, what catches it, what uses it, what is changed by it, is a small blue world turning slowly with life on its surface that has been shaped by this light for longer than it has known. The light arrives. It enters the atmosphere, where some of it scatters, the blue wavelength bouncing off air molecules in every direction, filling the sky with a diffuse, even glow that we call daylight. It reaches the surface of the earth, where some of it is absorbed by soil and water and leaves and skin, warming them, and some of it enters your eyes. When it does something that has nothing to do with vision. Tucked behind your eyes, connected to a region deep in the brain by a dedicated pathway, is a small cluster of nerve cells, roughly 20,000 of them, a tiny knot of tissue about the size of a grain of rice. It has been keeping time for your entire life, and for the lives of every human being who ever lived, and for the lives of the creatures that came before us, all the way back to organisms that were crawling out of shallow seas hundreds of millions of years ago. It is one of the oldest and most conserved pieces of biological machinery in the history of life on this planet. Its job is to synchronize the body to the day, to the sun, to the cycle of light and dark that has been turning steadily for the entire history of the Earth. It does this primarily through light, specifically through a signal that travels from specialized cells in the retina, cells whose only purpose is to detect the overall brightness and color of the environment, not to form images but to measure the quality of the light, directly to this tiny clock at the center of the brain. When bright light, particularly light rich in the shorter, bluer wavelengths that are abundant in morning sunlight, reaches these cells, they send a signal. The clock receives it. And in response, the brain suppresses the production of a hormone called melatonin. Melatonin is the body's signal for darkness. It rises in the evening as light fades, telling every cell in the body that night is coming, that it is time to slow down, to repair, to prepare for sleep. When morning light suppresses it, the message is equally clear. It is day. Be alert. Move. The two signals, light and its absence, have been the body's most reliable source of information about time for the entire history of our species. The practical shape of this is something you may already feel in your own life. People who get bright natural light in the first hour or so after waking tend to fall asleep more easily that night. The morning signal sets the clock, and the clock, running its roughly 24-hour cycle from that point, brings tiredness at the right time in the evening. People who spend their mornings in dim indoor light, or who work through the night and sleep through the day, often find their sleep fragmented and their energy unreliable, not because of any weakness of will, but because the clock is not receiving the signal it was built to receive. The evening side of this is equally important, and it is where our modern lives have introduced a quiet difficulty. The light from screens, phones, tablets, televisions, the soft glow of a laptop in a dark room contains a great deal of those shorter, bluer wavelengths. The clock in your brain does not know the difference between morning sunlight and a phone screen. It reads the signal and responds accordingly. Suppress melatonin. Stay alert. It is not yet time for sleep. This is not a moral failing or a character flaw. It is simply a mismatch between a very old piece of biological machinery and a very new kind of light source. The clock was calibrated over millions of years to respond to sunlight, to firelight, to the gradual dimming of the sky at dusk. It was not designed for the particular quality of light that comes from a glass rectangle held 12 inches from your face at 11 o'clock at night. The warmer, redder light of evening, the color of a sunset, of a candle, of a fire, is what the clock expects when darkness is coming. These longer wavelengths have very little effect on melatonin. They allow the body to read the approach of night correctly and begin the slow chemical process of winding down. There is something worth sitting with here. The light inside your phone, the photons bouncing off this screen or that one. Those photons were created by electricity, yes, but that electricity came, in most cases, ultimately from the sun, whether through solar panels or through coal that was itself compressed, ancient plant matter, ancient sunlight stored in the ground. The sun made the clock, the sun made the light, and somewhere in the gap between those two ancient things, we are finding our way. Knowing this does not mean you need to do anything differently tonight. You are already here, already still. The knowledge can simply rest with you, soft and quiet, the way all good things rest when the day is finally done. Let everything slow now. We have come a long way tonight, and there is nowhere else we need to go. Think for a moment, gently, without effort, about the full arc of what we have followed. A fusion event in the heart of the sun, in heat and pressure so extreme that nothing in ordinary life comes close to describing it. 4 tiny hydrogen nuclei pressed together until they became something new, and in that becoming, a burst of energy was released. That was 100,000 years ago, maybe more. Our ancestors were painting animals on cave walls, the whole of what we call history. Every civilization, every war, every invention, every piece of music ever written, every child ever born, none of it had happened yet. The energy that became today's sunlight was already on its way. It wandered. That is the truest word for it. It wandered through the dense interior of a star, absorbed and re-emitted and redirected over and over and over, with no destination and no intention, just energy moving in whatever direction the last interaction had sent it, through the dark and the heat and the immense patience of stellar time. It changed along the way. The fierce, violent gamma ray of its birth softened, step by step, exchange by exchange, into something gentler, something that a human face could turn toward and feel as warmth rather than harm. The journey transformed it, the way long journeys transform most things. And then, after all of that, after the radiative zone and the convective zone and the seething surface of the sun, it was released into space, into silence, into the vast unhurried dark between the stars. 8 minutes of pure, unimpeded motion, no obstacles, no crowd, just light moving at the only speed it knows toward a small blue world turning slowly in the dark. And it arrived. It fell on oceans and deserts and forests and rooftops and faces. It fell on your face sometime today, maybe through a window, maybe outside briefly between one place and another. Some of it scattered off the moon and came back down again, softer silver rather than gold. Some of it is still out there, still moving, having passed through the Earth's atmosphere and continued outward into the universe, never to return. But some of it reached you. You are made, in part, of star material, not metaphorically, literally. The carbon in your body, the oxygen in your lungs, the iron moving through your blood right now were all forged in stars that lived and died before the sun was born. You are an arrangement of ancient stellar debris, assembled by 4.5 billion years of chemistry and biology into something that can lie still in the dark and think about photons. And the light that spent 100,000 years finding its way out of the sun, that light found you. It warmed you. It set the clock inside your brain. It told your body this morning that it was time to be awake. And now, having done its work, it is gone, absorbed into matter somewhere, its energy dispersed, its journey complete. Your journey today is complete too. Whatever you carried into this night, whatever the day left on your shoulders, whatever the mind kept returning to in the quiet moments, it has been a long time since any of it was new. The sun has been rising and setting over human worries for as long as there have been humans to worry. The light has been making its patient crossing, again and again, indifferent to the content of our days, steady and ancient and unhurried. There is something in that steadiness that can hold you if you let it. You are lying still on a planet warmed by a star that has been burning for 4.5 billion years. The same light that fell on the first humans, on every generation between them and you, is falling now, or has just fallen, or will fall again in a few hours. The sun does not rush. The light does not worry. It simply travels and arrives and does what it was always going to do. The day is already distant now. Your body knows how to do this. It has been doing it every night for your entire life and for the lives of everyone who came before you. The clock is ticking down. The melatonin is rising. The world is growing softer at the edges. Somewhere, 150 million kilometers away, the sun is still burning, still converting mass to light, still sending photons on their long, slow, wandering journey outward. It will be doing this long after tonight, long after this year, long after anything we can meaningfully imagine. You don't need to hold any of that. The light has already arrived. You can rest now. And so we leave it here, not at an ending, because nothing in this story really ends, but at a pause, a still point in a very long journey. The day is behind you. The sun is on the other side of the world. The photons that crossed 100,000 years of stellar interior to reach you today have done their work and moved on. Let the dark be gentle now. Please, Well,